Hello, our next topic for A-level chemistry is alkenes. Alkenes has general formula CnH2n and a homologous series can be formed by putting the value of n. The first value for alkene is 2, n is equal to 2. All these compounds are called as unsaturated hydrocarbons. What is the main source? The main source is cracking of hydrocarbon. Cracking of hydrocarbon produce unsaturated hydrocarbon. More than 50% of crude oil fractions are of less consumption. That's why they are cracked to make them more useful fractions. In this case, we perform thermal cracking and catalytic cracking. As a result of cracking, the most important point is hydrogen gas is always produced. It never happens that hydrogen gas is not produced. Whenever we perform cracking, we get different types of the cracking product. Rather, we get mixture of a hydrocarbon. For example, if we have a butane molecule, if you have a butane molecule now, if we perform either thermal cracking, thermal means in the absence of air, if we strongly heat hydrocarbon, then approximately at 1000 degrees centigrade, all the bonds of carbon and hydrogen are broken and they once again arrange itself. Now, might be, initially at the first step we get these two hydrogen is removed and we get one butene and hydrogen. We can get one butene and hydrogen gas. Now, instead of these two hydrogen, the hydrogen molecule may be removed from this side and this will produce 2 butene and hydrogen. This may also be the product. Second chance. Now, as a third chance, it might be the process that bond is broken from this side and product is formed methane and propene, C3H6. That might be. Another product may be for some molecule bond broken from here and we get ethane and ethene. There are so many chances for rearrangement of all these atoms whenever a cracking is performed. Now, as a result of cracking, from one molecule we can get variety type of different types of products. Rather, we can say we get a mixture of different products which are further separated by the fractional distillation and we get wide variety type of the unsaturated and saturated small molecular mass hydrocarbons. As the molar mass of the molecule decreases, their volatile nature increases. As a result, their combustion become much more easy. That's why they are converted from long chain hydrocarbon to the small chain or small molecules, small molar mass molecules, which can be used as a fuel quite easily instead of a long chain hydrocarbons. Now, in comparison with all these saturated hydrocarbons, all these unsaturated hydrocarbons, these are much more reactive than alkanes or saturated hydrocarbons. Due to their reactive nature, the mixture of all these unsaturated hydrocarbons is called as naphtha, which is the feedstock of chemical industry. By performing quite easy or very quick reactions, all these unsaturated hydrocarbons perform addition reactions, and as a result of addition reaction we get variety type of the products. In our previous lectures we have already discussed the addition reactions of alkenes. Briefly, we can say that these unsaturated hydrocarbon CH3, CH double bond CH2, by the catalytic hydrogenation can be converted into alkanes, saturated hydrocarbon. Saturated hydrocarbon can be converted into saturated hydrocarbon. This is the example of addition reaction. Again, if we have ethene, we can add water into it in the presence of H3PO4 at approximate 100 degrees centigrade, and we can get CH3, CH2OH ethanol, which is also an example of addition reaction. Now, the most important is the addition of aqueous bromine or bromine water. This is used as a test to check the unsaturation. Bromine is red-brown color. Whenever this will be added and a reaction takes place, then red-brown color of bromine is discharged. This shows that the organic compound is unsaturated, producing halogenoalkanes. These are the different types of addition reactions which are performed by the unsaturated hydrocarbons or alkenes. The most important reaction of alkenes is with hot solution of KMnO4. Hot concentrated KMnO4 solution, which is a strong oxidizing agent that reacts and break the carbon-carbon double bond in hot condition wherever the double bond is present in alkenes. Number one, there are three chances. Number one, if alkene is simple, for example ethene, CH2, double bond CH2. If we heat this, if we bubble this gas through hot concentrated KMnO4 solution, what will happen? Now, the bond will be broken at this point from double bond position. As a result of oxidation, it is converted into carbon dioxide and water. How many carbons are there and how many hydrogen are there, depending upon them, the product carbon dioxide and water is produced according to the number of moles. But if If we have propene CH3CH double bond CH2, if we apply same conditions, now the complete oxidation of this carbon will take place, but this carbon will remain safe. This will produce aldehyde. This double bond will be broken from here, and atomic oxygen will take the place, producing CH3C double bond O and H along with CO2 and water. Now this aldehyde, if we perform this process for a longer time, then the compound will change into carboxylic acid. From the aldehyde, carboxylic acid will form as a result. Similarly, if the compound is 2-butene, if the compound is 2-butene, CH3, CH double bond CH3, and we apply the same conditions, now the bond will be broken here, and both of the molecules will be converted into the respective aldehyde, and then both of these will be converted into respective carboxylic acids. Okay. Now next, if the compound is, for example, CH3, CH3 double bond C, then CH3 and then CH3. If the compound is this one, means if we name this compound 2,3-dimethyl-2-butene, if we apply the same conditions of hot concentrated KMnO4 solution, definitely bond will be broken from here. Now the atomic oxygen produced will take the position, and as both of these carbon has no hydrogen, so further oxidation will not take place. As a result, what will be the product? We will get two molecules of ketones, CH3, C double bond O and CH3. Two molecules of ketone. Now, these ketone molecules will not be further oxidized. In this manner, if we want to produce ketone, this is the best method. If we want to prepare the carboxylic acid or aldehydes, this is the best method. We can heat alkenes with a hot concentrated solution of KMnO4, and that solution will definitely break the double bond wherever this double bond is present. Remember, always if double bond present on the terminal carbon, that last carbon will be converted into carbon dioxide and water, and rest of the molecule will be converted into either aldehyde or in ketones. This is the most important reaction of oxidation of alkenes. Now, all these molecules, unsaturated hydrocarbon, as we have discussed, they are capable to perform addition reaction. Now, addition reaction is the main property of alkenes. Now, alkenes also show addition polymerization. Addition polymerization. Addition polymerization. Addition polymerization. As we have already discussed, reaction, what we will get? If this is n number of monomers, definitely we will get polymer, which will be called as polythene. This will be the structure of polymer, and this will represent the polymer molecule. All these unsaturated hydrocarbon, for example, we have already discussed that there is CH double bond CH2 having one benzene ring. This is called as styrene or phenylethene. As it contains a double bond unsaturated, definitely it will also polymerize. Now this benzene ring might be at the upper side or at the lower side of the longer chain, or might be alternatively. So many chances are there one polymer might be just like this. Second polymer we can also write down just like this. Similarly, from a given set, from a given structure of a polymer, we can also identify the monomer depending upon, for example, if we have long chain, we have to select our monomer. We have to select monomer. We know that the double bond can be created between two adjacent carbon atoms, as there is no further carbon atom present either at the lower side or upper side. That's why the double bond can be observed between two adjacent carbon atoms. Double bond cannot be formed between this carbon and this carbon. Double bond can be formed between this carbon and this carbon only. That's why it means this molecule is indicating that this is our monomer. If we write down here separately, this will become just like this: fluorine, and fluorine. Now, one valency of this carbon and one valency of this carbon, both will combine, producing double bond. In this manner, from a given structure of a polymer, we can identify the monomer from which the polymer is formed. Now, all these polymers are of different types. Some of the polymers are biodegradable and some of them are non-biodegradable or plastics. Biodegradable substances are quite helpful in controlling the trash and the pollution problem, but the non-biodegradable substances are a very big problem for the disintegration and for the pollution as well. I have explained all the concepts regarding alkenes and their allied topics. Hope you have understood all these. Please comments, like, share and subscribe my YouTube channel for the upcoming video lectures. I thank you all.